Okay, good morning. So today we are going to see the Elasticsearch, Kibana, and Spark streaming. Okay, we'll try to make the overall project. Try to understand the relation or like how to connect Elasticsearch, Kibana, Spark streaming together in order to get auto refreshing dashboards of multiple multiple uh, views, we can say. Or so basically we are going to create graphs, charts, and then create a dashboard out of it and try to make it auto refreshing to show us on the screen. Okay, so we will start. So Spark streaming, we have done quite a few things yesterday. Got to know that what is Spark streaming, how about Spark streaming context. Okay, we have created Spark streaming context, and then it started with sending the messages from the local host from one port. Then we have seen that how stateful transformations can be done, in which like the historical data will be stored as a checkpointing process on the HDFS directory, and it will be used for the current calculation. So it is like kind of aggregation on the range from history to the current values. Okay, we have seen that how if we actually start keep sending the words, how it will be automatically incrementing the counts for a particular words and will show us. Okay, so basically either you can show it on the screen, or you can just store it on, right? There are a few more things, and in Spark streaming that you can perform. So let's start with Elasticsearch. Okay, so what I have on my system is there is these are some packages actually. Okay, so when you talk about Elasticsearch, so there is one Elasticsearch 5.2. So this is what actually we are going to use, and then there is Kibana 5.2 Windows. So what I will do is I will upload this and will share with you, so you need not to download it separately. And what you just need to do is make some changes in configuration in order to run it on your own system. Okay, so basically when you talk about Elasticsearch is a, you can say it is a document store. Okay, and just like this document, right? So this document, so when you do control find, and it will start whatever you write and try to search it, it will basically give you the way to search it right there. I mean, the whole data would be there on the single document. Okay, so Elasticsearch also provides such capability of searching. Okay, so all that you input or all that you store in Elasticsearch is completely a JSON information. Okay, so and when you talk about JSON information is basically structured information. So you will have tags associated with every information and then store it like that. Okay, so what I will do is basically Spark material, I will store them over here. So Elasticsearch zip and Kibana zip, I think they are not more than few MBs, only 62 MB. So when you start Elasticsearch, so basically I will just let you go through the configuration part that is required. That is not a big thing. So basically again it is having the similar structure that every other software will have, like having some directory and then bin structure, lib structure, etc structure. Okay, so this is the path where my bin folder is there. So either you can set this path. So I have actually installed what I mean, I just keep this directory on my Windows basically. Okay, and you can run it on Windows and Linux and then with the similar way. Okay, so you can download it for Linux, you can download it for Windows. There is a website for Elasticsearch. You can just search it, and then you will find the latest versions to be downloaded. So I'm going to use this 5.2 currently. I think the 5.5 is there, Elasticsearch. Now Elasticsearch is actually there is a stack that is what is called ELK, Elasticsearch, Kibana, and Logstash. Yes. Okay, so there is a ELK stack that is actually very famous for doing ELK. E for Elasticsearch, then L is for Logstash, and then K is for Kibana. So Kibana is these three things are very famous together, and like it's like a complete use case in itself. That Logstash is again kind of a Flume or Kibana, or not Kibana, basically Flume or Kafka or something like that. So this Logstash is a tool that actually helps you to gather the logs from the Linux basic files or Linux things. So it will whatever it collects, basically it actually feeds Elasticsearch with whatever logs it is actually getting. Okay, so that logs that is going to store in Elasticsearch is completely in JSON format. Okay, so Elasticsearch is very famous in terms of searching the documents for a particular keyword. Let's say you are searching whatever you want, so it's just like control find, and then on the terabyte of data, basically you are going to do a very fast text search. It's mostly text search. It's not a database first of all, though the data is structured, but it is not a database. You cannot do select star from or that kind of queries on the Elasticsearch. Whenever you want to interact with Elasticsearch, it's only the JSON and REST API based communication you can make. Okay, so since it is a JSON format, you can easily Elasticsearch has provided you the APIs to connect to it, and then you can then finally create so though there are some tabular structures are there, but it is not a database. Okay, so I will tell you that what are all the terminologies that you should use for interacting with Elasticsearch, how to make so there are certain things like tables, mappings, index, okay, words, topics, all those things are there. So we need to just like map that whatever we know as of now for a particular RDBMS, and what are the corresponding things in Elasticsearch. Okay, so that will give you an idea of how the data is structured in Elasticsearch. So as soon as you enter the data into Elasticsearch, within 1 second it is searchable. It means that whenever now from the front end or whoever is connected to Elasticsearch is trying to find the word search, free text search, basically it is as soon as the data is entered, after 1 second the data is available for search. Okay, or it is actually searchable. Okay, that is so fast in terms of giving the search responses. Okay, because you need not to write query, you need not to plan anything, you need not to do query planning anything. It is just a raw search on the plenty of text. Okay, and it is so again then it is again a fault tolerant, because it is having the replication factor as 2 by default, just like we have a HTFS directory. Okay, whatever blocks that we are splitting and storing, the same thing is called shards. Shard in Elasticsearch. Shard is basically again RDBMS concept only. So instead of storing, because the thing is there could be multi, and it is a scalable solution, and you know what is scalable means, right? So this is Elasticsearch is scalable. It means that is horizontally scalable. You just need to add the number of nodes, and then for a particular data, it creates multiple shards. So maybe the data is for a particular thing, that data is related to a particular table, you can say, but it cannot be stored all at a single machine. So Elasticsearch keeps sharding it. Sharding means it is actually partitioning it and then storing it 2 copies of every shard on in the cluster. Logstash we are not going to see it. Kibana is then a dashboard visualization tool. Okay, so this it is just like Cloudera, not Cloudera, basically it is just like Tableau. So basically, though it does not provide you the JDBC connectivity to any other database, it is actually built only for Elasticsearch, and it is seamlessly getting get connection with Elasticsearch. So as soon as you start Elasticsearch, there are some default ports, with some default settings. It will start and give you the connection to feed the data into it, and then you can interact with it in order to get the data search. So kibana has all the properties of Elasticsearch to connect. So basically within the kibana configuration, you will have Elasticsearch port, Elasticsearch server, Elasticsearch whatever the server, the cluster name and all. It is automatically by default it is getting set to connect to Elasticsearch. Whenever kibana is getting started, basically if your Elasticsearch is running, kibana can pull the data and then show you the dashboard. So it is like having beautiful graph, chart, world map, and everything is there. So basically in our use case, instead of log stash, we are going to use Spark streaming. Okay, and then we are going to feed this Elasticsearch whatever we are collecting. So we are actually now on the top of it we do have Twitter. So Twitter will we will collect the tweets on Twitter. Spark streaming will feed the data into Elasticsearch, and finally we are going to see the dashboard on Kibana. Again, that is all auto refreshing. As soon as the tweets come, it will follow all the channel till Kibana, and then the dashboard will be automatically refreshing. Okay, so you need not to do you just need to watch it after making it. So let's go through some more details in Elasticsearch. Okay, so what I will do is basically this is my Elasticsearch. I need to just Control C, and then I'm going to start on. So I'm not going to start any VM on VirtualBox basically, but I just need to okay, so I'm going to start a command line and we'll paste okay, so this is my bin directory of Elasticsearch. Okay, so wherever you extract, you just need to put that, and then just do elastic.search. So this is a command that will start the Elasticsearch at the backend. Okay, there is a configuration file, that is what is called Elasticsearch YML, that is under the config directory. If you open it, so most of the things are commented. What you just need to know about the thing is so this is the basic host 102. So this is a local host basically. Okay, so whenever you install it on any other cluster, basically you just need to provide what is the host name where you have this, and then the port. So basically these are three properties that you just need to have. So though I already shared it with you, so basically if your hard disk is so this is actually warning and critical messages generated if the amount of hard disk that is remaining on your system is not that much in order to hold the data for Elasticsearch. So the Elasticsearch, it actually assumes that you are going to feed the data quite fastly and few GB per second or like that kind of thing. So it actually requires some default setting of the amount of hard disk to be remaining on the system so that it cannot go out of memory. Okay, go out of hard disk basically. There are these three properties. Rest everything is okay. I mean, what is the port? Basically, the port is 9200. So this is the port from where you can access the Elasticsearch. Okay, but whatever you are sending, it should be a REST API call basically, and it will just give you the response back in the JSON format. Okay, so currently it is started now. Basically, you just need there is not much configuration you need to provide. So basically, there are few indices. Now suppose it is running, then what to do with it is basically you just need to hit it on using a web browser and try to access some of. So I will open one thing, 9.127 dot. So this 9200 is that port. So if you hit it, it will give you the response like this, okay, in the form of JSON. So basically it will tell you what is the cluster name, what are the UID number. So this is actually the version of our thing. Then build hash date is snapshot version, and tagline for search. So this is actually telling you that this last search is started and it is getting the. Okay, so now there are a few more things that you can do. So there are multiple ways to interact with it. Either you can use any REST-based tool, or utility like Postman or Fiddler. Okay, and that will actually help you the thing. But the best way to interact with Elasticsearch is Kibana itself. So what I'm going to do is I will start Kibana now. Kibana also can be started like that. Okay, so this is the Kibana dashboard, and then in config, if you go to its config, it will tell you that where it is going to connect. So it is going to connect to server localhost, so that is our end server. This is the server port where you will access Kibana, but ultimately it is going to interlink with this Elasticsearch URL that is actually running on 9200. So this is by default configuration with Kibana, that whenever Elasticsearch is running, Kibana can automatically detect, and it will just interact with it. Okay, the rest of the things are also you may need to do further adjust, but they're all commented means they are all defaulted to those values. Okay, these are the okay, so I am going to open one command line as one more command line. Actually it opened, but I don't know what was that. And now this time we need to go to Kibana bin directory. You can also double click on this, it will also actually open you the command line, and then Kibana bit. And then we require so it is getting started. The port of Kibana is 5601. Now the on this particular menu, on this particular menu you will have discover, visualize. Okay, visualize will give you lot of options to create charts from. You can so this is actually Kibana, and then there will be a dashboard. So here you will see multiple graphs. Okay, you will have some on the top. If you see, basically there is the last 15 minutes data it will show, or you can know if you click on it, you can tell that how fast or how slow you are trying to refresh your dashboard. Okay, there are multiple things that we are going to see. Okay, then there is a timely on, even I don't know what about it. Okay, then there is a dev tool. So this dev tools basically will give you the way to access the Elasticsearch. So it is actually this is actually connected with Elasticsearch. Status changes from red to green. It is saying ready. So basically if you okay, so if you just do this play button, it will tell you what is there inside Elasticsearch. This is the best way to. Now whatever we are doing, we are actually doing with Elasticsearch. So basically you can just try to see get. So there is a way to interact with it. Let's go get all indices. So these are currently stored indices. Now indices is what basically this is nothing but it would be a database terminology for RDBMS. Okay, so Elasticsearch, let me make it bigger. Are you able to see this? Okay, so these are few indices. Okay, so this Twitter, and I might have created it previously, and a yellow option attraction. So basically these are all. So this dot kibana will be like kind of default. It will be there. You cannot delete it. Basically, suppose if you want. So these indices, whatever we are actually selecting here, these are actually kind of database. Okay, so now let's look more into the Elasticsearch terminologies, how it actually organized. So Elasticsearch is a near real-time search platform. What this means is that there is a slight latency, normally 1 second, from the time you index a document until the time it becomes searchable. Okay, so it is almost near real-time. Then what is cluster? Cluster, we already know what is a particular cluster. So cluster is nothing but it's a group of nodes or a group of machine. And then we do have node, right? So a node is a single server. We already know what the node means basically. Then comes to index. So this is something. So index is basically a collection of documents that have somewhat that is somewhat similar to characteristics. Characteristics, for example, you can have index for a customer data. So I do have one diagram. Yeah, this one. So basically, when you talk about index, so these are some terminologies for Elasticsearch, and these are corresponding terminologies from RDBMS. Okay, so you have index. So index is mostly database. If you are creating shard means just the partition of data. So basically, within RDBMS, you can have shard. Shard means that suppose in one database, if there are if the data, if the size of data is too large, basically you need to partition the data that and then store on the separate machine. Okay, that is what is called a shard. Shard is basically a partition. Then whatever we do have mapping and Elasticsearch is called table in RDBMS. Okay, so one database, so one index may have multiple mappings. Okay, and then field. So within mapping there would be field. Under the table there would be field. So field to field is okay. And then what is tuple? Tuple means right a single record in RDBMS is called JSON object in Elasticsearch. So what you just need to know is only these terminologies. Basically, they are actually exactly mapping with the RDBMS. So we can have multiple mappings in the index. Okay, and every mapping. So mapping is a table, right? So if the table is very big, it cannot be stored on the single machine. Basically, the shards will be automatically created out of it, and then shard will be stored on the different nodes with the replication factor of 2. So the default replication factor in Elasticsearch is 2. Okay, and finally we will have fields and JSON objects. So we can create the document like that. And what is document basically? Index is database. Type is basically like logical category. What is the type? In general, a type is defined for documents that have a set of common fields. Okay, type. Mapping is again database. Document is a basic unit of information that can be indexed. For example, you can have a document for a single customer, another document for a single product. Okay, so basically it is document. So, but there is no corresponding. Shard replicas, that is done. Document, mapping, type, index. So index, shard, mapping, field, and JSON object. So I think document is a JSON object only. So basic unit of information that can be indexed. So it is only, for example, you can have a document for a single customer, another document for a single product, another for single order. So this document is executed in JSON JavaScript object notation. JSON basically is an internet data. So within an index and type. So type is basically you can store many documents as you want. Note that although a document physically resides in an index, the document actually must be index assigned to a type of. So basically these are terminology basically, but they are actually somehow related to database only. I mean, it seems confusing, so we need to stick on this particular thing. They are index, mapping, field, JSON objects. Now what two different terms comes here is mapping and document and type. Okay, so index is a database. With an index you can define one or more. So basically I also have one book of it. Elasticsearch guide. Okay, I will share this with you. Okay. So you can go through this, you will get a clear idea about it. But that mapping is these are the key concepts of Elasticsearch, where we do a node, cluster, index, type. So type and mapping is the same thing. Okay, so it is a collection of documents, and document and so mapping is table, index is database, so type is also table. That's what actually in the document. And we do have document as a collection of fields. It means that mapping is a table and document is your JSON object that has fields inside it. And shard, that is, so these are only the basic concept. Replicas is also okay. Okay, so only this. So type and mapping is the same thing, and document is one JSON object. Okay, so when I say document, so it is like piece of information, or you can say document is basically a record itself. Okay, that is indexed and searchable, because only the record can be searched. So we are actually doing select star from. So with this we are actually searching records, right? And record is nothing but it's like a document. So now it is clear. So type is mapping, okay, and basically here you will say either type or mapping, or this is JSON object or document. Okay, so these are the two missing words that we are actually. So index is a database, shard is shard, mapping and type is table, field is basically the individual field of table, and or you can say individual field of JSON object, and JSON object is a document. So whenever you say document, it is a complete record. Okay, so if I convert this whole thing into of JSON key value pairs, basically it is becoming a document that you can store in Elasticsearch, and it will be searchable as soon as you enter. After 1 second it is going to be searchable. So it will take 1 second to get indexed into the document, and index means like index will always be faster. So it is all internal mechanism to index the document depending on the keywords and all, and it will be fastly searchable in the Elasticsearch node. Okay, so basically what we are doing here in Kibana is we are getting so index. So these are all the available databases. So when you kind of index your databases, and then in this database we will have mappings. That mapping will be a table, and then in that table basically you will have data stored. So how to create, how to delete, those are also, so whatever we are doing is REST API calls basically. Okay, and what is, so if we have delete, we have get, we have put, we have post. These are all the they're all REST API based